Hello my dear students, I warmly welcome you to CR Digital Classes. So in this lecture, we are going to discussing the continuation problem of Legendre's linear equation. In the last lecture, we discussed that the general derivative and unit for introduction amma. Okay. Along with unit for introduction, we discussed Legendre's linear equation derivation. Why? Because the derivation problem in the previous question paper they asked, especially Usmania University question paper. Okay. So based on that Legendre's linear equation, we have one more problem. This problem repeated so many times in the final examination, amma. Pay attention while explaining, okay? Listen carefully. Solve 2x plus 3 whole square d square y by dx square minus 2 into 2x plus 3 into dy by dx minus 12y is equal to 6x. Whenever you see a differential equation in this format, it is easy to identify it is belongs to Legendre's linear equation. Why? Because in the previous lecture, general derivation of Legendre's equation, we discussed that general form is a suffix 2 ax plus b d square y by dx square minus plus a1 into ax plus b dy by dx plus a naught into y is equal to something function q of x. Okay, so here you can see ax plus b form. Ax plus b form. Ax plus b is nothing but 2x plus 3. 2x plus 3 whole square d square y by dx square minus 2 into with constant coefficients. This term is linear factor. 2x plus 3 is a linear factor, but coefficient of that linear factor is constant. Here you have that constant 1 amma. Here you have constant minus 2. Here you have constant minus 12. Okay, it is purely in Legendre's linear equation format only. So now see the solution amma. Given Legendre's linear equation is this is that. Okay, that is equation. Given equation 2x plus 3 whole square d square y by dx square minus 2 into 2x plus 3 dy by dx minus 12y is equal to 6 into y. Above equation can be written in symbolic form. That means that is the general form of second order equation. Now simply we can write in that a differential operator form. The differential operator form is that symbolic form. Symbolic form is nothing but 2x plus 3 whole square d square y by dx square. D square y by dx square, simply you can write a d square, capital D square. Okay, capital D square minus 2 into 2x plus 3 dy by dx. Dy by dx simply we can write capital D minus 12 into, if you take small y common, so therefore small y into 6x. Okay, equation 1 can be reduced to linear equations with constant coefficients by the suitable substitution. Equation 1 is nothing but this is the symbolic form. This equation 1 is a non-homogeneous Legendre's linear equation. This linear equation we can convert or we can reduce into linear equation with constant coefficients. Here we have 2x plus 3 whole square. Equation 1 can be reducible to linear equations with constant coefficient by the suitable substitution. Problem based on Cauchy-Euler equation, problem based on Legendre's linear equation, you have to substitute a suitable function to solve the given differential equation. Here, in place of 2x plus 3, you have to substitute e power z. For that Cauchy-Euler problem, you have to take x is equal to e power t. For Cauchy-Euler problem, you have to take small x is equal to e power t. For this problem, 2x plus 3 is equal to e power z. So therefore, then from this condition, z is equal to, if you send this small e value to LHS, it will become logarithmic function. Z is equal to log 2x plus 3. So therefore, now just keep that value as aside amma. Z value log 2x plus 3, just remember. Now from the continuation of this equation 2x plus 3, if you send that plus 3 value to RHS, that will become e power z minus 3. So we have to derive x value amma. X is equal to, if you send this 2 value also to RHS, e power z minus 3 by 2. That is the x value. So what is the reason to derive x value amma? In general derivative, we discussed that x into dy by dx. X into dy by dx. So therefore, here d1 is equal to d by dz. Let or you can consider d capital D suffix 1 is equal to d by dz. That is the differential operator. Okay. Then 2x plus 3 into capital D1 is capital D is equal to 2 into d suffix 1. Okay, in the problem amma, in the problem you have here first thing is here you have 2x plus 3 into dy by dx. That 2x plus 3 dy by dx we are writing 2x plus 3 capital D. That is we are writing 2 into capital D1. Why? Because if the total word if you take d suffix 1 amma, then that coefficient is minus 2 na. So therefore we are writing 2 into d1. Minus we can write down later on. Okay, just coefficient is 2 na. So the total value we are writing as 2 into d suffix 1. That is about first term. Now come to second term. Okay, second term how you can write 2x plus 3 whole square d square. 2x plus 3 whole square d square how you can write a square. Okay, a square into d1 into d1 minus 1, where what is the a value 2. So therefore 2 square, that is whatever that coefficient value is there. So for that only you will get 2 square. 2 square value 4 d1 into d1 minus 1. సో ఈ వాల్యూస్ మీకు ఎలా వచ్చాయనేది మీకు జనరల్ డెరివేషన్ లోనే చాలా క్లియర్ గా ఎక్స్ప్లెయిన్ చేశానమ్మా. సో జస్ట్ గో త్రూ దట్ వీడియో వన్స్ అగైన్. ఓకే, సో నౌ సబ్స్టిట్యూటింగ్ ద అబోవ్ వాల్యూస్ in equation number 1, wherever you have these values amma, substitute these values. So therefore 4 into d1 into d1 minus 1 minus 2 into 2d1 minus 12 into y into 6 into x plus, in place of small x you have e power z minus 3 by 2. Okay, so therefore now multiply with 4d1. 4d1 value into d1 4d1 square minus 4d1 and minus 2 into 2d1 minus 4d1 minus 12 into y is equal to, so 2 1s are 2 3s amma. So therefore multiply with 3. 3 into e power z minus 3 into 3 is the 9. Okay, so therefore if you cancel this value, amma, so you will get 2 1s are 2 3s ana. So therefore multiply with 3. 3 into e power z minus 3 into 3 9. So now simplifying here, minus 4d1 you will get minus 8d1. So therefore 4d1 square minus 8d1 minus 12 into y is equal to 3 into e power z minus 9. That is taking as equation number 2. Equation number 2 is of the form f of d1 into y is equal to q of x. What is that equation? Where it is the equation of linear differential equation with constant coefficients. Okay, so therefore f of d1 is equal to 4d1 square minus 8d1 minus 12 and RHS q of x is equal to 3 into e power z minus 9. We have exponential function, we have constant function. So it is a trivially we can find that complementary function. Why? Because whenever you have an equation in this format, okay, with constant coefficients, so to find the general solution we are going to use the procedure complementary function and particular integral. How you can calculate complementary function amma? By using the auxiliary equation. Auxiliary equation is f of m is equal to 0 in f of d. Okay, wherever you have f of d1, just to write f of m is equal to 0. So therefore, so 4m square minus 8m minus 12 is equal to 0. So take 4 common amma from that equation, m square minus 2m. If you take 4 common, so therefore m square minus 2m minus 3 equal to 0. Send that 4 value, so it will become 0. So remaining value m square minus 2m minus 3 equal to 0. So for that value, if you apply the root sum, m square minus 3m plus m minus 3 is equal to 0. Take a small m common from the first two term, so then you will get m into m minus 3 plus 1. Take common from the last two terms, then you will get m minus 3 equal to 0. So therefore m minus 3 into m minus 3, again you have common, and the remaining terms m plus 1 equal to 0. So there you will get m is equal to minus 1 and m is equal to 3. You will get two different roots amma. These two different roots are real roots only and distinct values. So whenever you have real roots and distinct value amma, it is easy to write complementary function y suffix c is equal to c1 e power minus z. That means minus 1 into z, first root. So y suffix c is equal to c1 e power m1 into x plus c2 e power m2 into x kada, where what is the m1 value? M1 is minus 1 amma. Minus 1 is nothing but minus z only. Ikkada variable z kada, minus z plus c2 e power m2. m2 is nothing but second root 3. 3 into z. So now, since we have z is equal to log x, z is equal to log 2x plus 3 na. Now substitute that value. Okay, wherever you have z, substitute that value here. So therefore, in place of z, we are substituting. In place of z, log 2x plus 3, we are substituting. In place of z, we are substituting log 2x plus 3. Okay, send this minus 1 value to power of logarithm. Send this 3 value to power of logarithm. Then you will get y suffix is equal to c1 into e power log 2x plus 3 whole power minus 1. Okay, so then you will get remaining terms c2 e power log 2x plus 3 whole cube. You know very well the famous formula e power log f of x. The formula is again f of x only. Whatever the value you have in place of f of x, again you will get the same value. It is again e power log f of x only. Here in place of f of x, you have 2x plus 3 whole power minus 1. 2x plus 3 whole power minus 1. Here in place of f of x, you have 2x plus 3 whole cube. So therefore that we are writing those values only. C1 into 2x plus 3 whole power minus 1 plus C2 into 2x plus 3 whole power minus 3. That is taken as equation number 3. That is a complementary function. First substitute m1, m2 roots and substitute z value. Apply the logarithmic properties and apply the formula and simplify. You will get that complementary function. To find that complementary function, it is easy only. Now after that, particular integral y suffix p. Okay, so RHS value y suffix p is equal to 1 by f of d1 into q of x. So therefore y suffix p is equal to write down 1 by f of d value 4 d1 square minus 8 d1 minus 12 into q of x value RHS 3 into e power z minus 9. Y suffix p is equal to, first to apply that 1 by f of d1 to e power 3z and after apply to constant function. So therefore 1 by 4 d1 square minus 8 d1 minus 12 into 3 into e power z minus 1 by 4 d1 square minus 8 d1 minus 12 into 9, where 9 is a constant function. In unit 3 introduction video and after that introduction video we discussed a lot of problems based on that methods. Okay, so here we have two methods. So the first method is the exponential function and the second one is that the constant function. Now from equation number 4 we have to consider two functions separately. Those two functions are, here you can see this is the first function and this is the second function. Now consider this value first. Consider this value first. Consider y suffix p is equal to 1 by 4 d1 square minus 8 d1 minus 12 3 into e power z. If you compare with e power ax is equal to e power z, so therefore small a is equal to 1. That means e power az akkada, not x. E power az. So a is equal to 1. So substitute d1 is equal to small a value. What is the a value? 1 in above equation. Then y suffix p is equal to, wherever you have d1, substitute a value, a is equal to 1. 4 into d1 square, that means 4 into 1 square minus 8 into 1 minus 12 into e power 3z. So therefore 3 by 4 minus 8 minus 12 by e power z. So therefore y suffix p is equal to minus 3 by 16 e power z. That is taken as equation number 1. So therefore you got the first half part of equation number 4. Now for the second half part equation number 4, again consider y suffix p is equal to 9 by 4 d1 square minus 8 d1 minus 12 into 1. That 9 how you can write 9 you can write 9 into e power 0 into z. So therefore 9 into e power 0 into z, e power 0 only. 9 into e power 0 into e power 0 value 1 only, 9 into 1 9. So without loss of generality we are writing that 9 value as 9 into e power 0 z. So therefore where if you compare a value is the 0, then substitute d1 is equal to 0 in the given equation. So therefore yp is equal to 1 by 4 d1 square minus 8 d1 minus 12 kada. So wherever you have d1, substitute d1 is equal to 0 in the denominator. Then you will get 9 by only constant term minus 12. 9 by minus 12 means 3 3s are 3 4s are. So therefore y suffix p is equal to minus 3 by 4. So therefore substitute equation number, take it as equation number 6. Substitute equation number 5, equation number 6 in equation number 4. Okay, then you will get the complementary function y suffix p is equal to this is that equation number 5, and this is that minus of minus 3 by 4, equation number 6. From those two values you will get that the complementary function as, so y suffix p is equal to minus 3 by 16 into e power z plus 3 by 4. Okay, now again substitute z value. So therefore y suffix p is equal to minus 3 by 16 into e power you will get log 2x plus 3, e power log 2x plus 3. So e power log f of x and again f of x value 2x plus 3 only na. So therefore 2x plus 3 plus 3 by 4, that is a particular integral. So it is easy to write down the general solution after getting that value. So therefore general solution of equation 1 is given by y is equal to yc plus yp. So that is taken as equation number 8 amma. Substitute equation number 3 complementary function, equation number 7 particular integral in equation number 8. So therefore this is the general solution. Y is equal to c1 2x plus 3 whole power minus 1 plus c2 2x plus 3 whole power 3 minus 3 by 6 into 2x plus 3 plus 3 by 4. So enta easy gundo okkar observe cheyandi problem. Okay, but this is the total explanation of this problem amma. Be careful while writing these values amma. Okay, so if you understand these values clearly, then you can write anything amma. Okay, so here while you are applying these values amma, 2x plus 3 into d equal to 2d1 you wrote. So where if you compare 2x plus 3, sorry, if you compare 2x plus 3, it is equal to ax plus b amma. So what is the a is equal to? A value is equal to 2. In the general formula, so ax plus b into dy by dx is equal to a into d1 only. So therefore that's why we are writing 2 into d1. In the next step amma, same ax plus b whole square d square y by dx square is there na. So that is also we are writing a square into d1 into d1 minus 1. So that is the value. So therefore, so in that format we are writing all the values amma. So therefore this is the total explanation of this problem. I hope you understood this problem very well. In the next lecture we are coming with the next method. Okay, make a perfect practice, prepare well. Until bye. Thank you.